Americans spend $29 billion every single year on air conditioning. That is not a typo. $29 billion just to move heat from one side of a wall to the other. Air conditioning now consumes 12% of all household electricity in this country, and that number is projected to hit 20% by 2040. Globally, air conditioning generates 4% of all greenhouse gas emissions. That is twice the entire aviation industry. Every flight on every airline on Earth produces half the carbon footprint of keeping our living rooms at 72 degrees. The global HVAC market is worth $299 billion and climbing toward $400 billion by the end of this decade. There is zero financial incentive for anyone in that industry to tell you what we are about to tell you. People living in the Persian desert solved this problem 3,000 years ago with a hole in the ground. Here is the physics they do not teach you. Below 6 to 10 feet of soil, the temperature of the Earth stabilizes. It barely moves. In Chicago, the ground sits at a constant 55 degrees Fahrenheit, year-round. In Atlanta, 62. Denver, 58. Even in Phoenix, where summer surface temperatures can melt asphalt, the Earth 6 feet down holds steady at 67 degrees. Minneapolis drops to 52. Up on the surface, temperatures swing wildly from -20 in January to 105 in July. Underground, the shift across an entire year is less than a single degree. Soil weighs 100 to 125 pounds per cubic foot, and moving that mass by 1 degree requires 20 to 30 BTUs per cubic foot. The Earth absorbs summer heat so slowly that by the time warmth penetrates 6 feet down, the season has already changed. This thermal lag is why root cellars kept vegetables fresh for centuries. It is why wine caves maintain perfect storage temperatures without a single watt of electricity. Oak Ridge National Laboratory in Tennessee has been monitoring and documenting these ground temperatures for decades. This is not theory. This is measured, published, peer-reviewed data. 3,000 years ago, Persian engineers looked at this same physics and built something extraordinary. They called them qanats, underground water channels dug at a slight slope, sometimes running for miles beneath the desert, with vertical shafts spaced along the route for access and ventilation. Above ground, they built windcatchers called badgers, towers rising from rooftops with directional openings designed to catch prevailing winds and funnel them downward into the building. When the wind shifted direction, the leeward side of the tower created a vacuum using the Coanda effect, pulling air upward and drawing cool replacement air from the underground channels below. Hot desert air entered the windcatcher, got pushed down through the qanat where it passed over cold water and cold earth. By the time that air entered the underground summer room, a space they called a shabastan, it could be 18 to 27 degrees cooler than outside air. No moving parts, no electricity, no refrigerants, nothing to break, nothing to replace, nothing to plug in. Go to the city of Yazd in Iran today, and you can walk inside domed chambers rising 60 feet high with walls 6 feet thick at the base. Those walls were made from sarouj, a mixture of sand, clay, lime, goat hair, and egg whites that achieved insulation values exceeding modern fiberglass bats. Archaeological teams with modern temperature monitoring equipment have documented these interiors, maintaining 75 to 80 degrees through summers, exceeding 115 degrees outside. A 30 to 40 degree temperature differential, achieved with materials you could find in a barnyard. Some of these systems are still functioning after 1,000 years of continuous use. UNESCO recognizes several qanat systems as World Heritage Sites. This is not fringe history. This is documented, protected, globally recognized engineering. And the Persians were not alone. Every major civilization on Earth discovered this independently. Romans cooled their villas the same way. At the Villa of the Mysteries outside Pompeii, archaeologists discovered channels designed not for heating, but specifically for cooling. The Roman engineer Frontinus wrote about subterranean air passages providing summer comfort in elite homes across the empire. In Korea, the Ondol system dates back 3,000 years. Underfloor air channels maintained interior temperatures between 64 and 72 degrees through brutal summers and equally brutal winters. In the American Southwest, native peoples built semi-subterranean pit houses for 8,000 years, utilizing earth contact cooling as a fundamental building strategy. 5,000 years of proven engineering across every inhabited continent. Then, in less than 1 century, it vanished from Western construction entirely. Here is how that happened. In 1902, Willis Carrier invented the apparatus for treating air in a Pittsburgh printing plant. It was designed to control humidity for paper, not to cool people. But by the 1920s, the Carrier Corporation saw a bigger market. They launched the Weathermaker campaign, positioning mechanical air conditioning as the symbol of modernity, progress, and American prosperity. Their marketing materials explicitly framed passive cooling techniques as primitive and unsanitary. A 1930 Carrier Engineering Corporation manual dismissed earth contact cooling as suitable only for cellars and food storage. In 1927, the first model mechanical codes emerged, and the heating, ventilation, and air conditioning industry representatives were heavily involved in writing them. By 1945, the post-war building boom had standardized mechanical cooling as the only acceptable approach to thermal comfort. Passive alternatives did not just fall out of fashion, they disappeared from architectural education entirely. ASHRAE codified mechanical cooling as the baseline assumption for all thermal comfort calculations. By 1980, fewer than 3% of American architecture programs taught passive cooling strategies. The technology was not disproven. It was not found to be dangerous or ineffective. It was systematically removed from professional memory. Now, here is the number. The HVAC industry absolutely does not want you to see. Your backyard air conditioning unit, the one you paid $10,000 for, achieves a coefficient of performance between 2.5 and 3.5. That means for every unit of electricity you put in, you get about 3 units of cooling out. A thermal labyrinth, which is just the modern engineering term for an earth tube cooling system, has been measured across 47 installations worldwide at an average coefficient of performance of 28.7. 28 versus 3. That is not a marginal improvement. That is an order of magnitude. That gap represents billions of dollars the HVAC industry would lose if this knowledge became mainstream. The only electricity these systems require is a small fan pushing air through buried pipes, consuming 50 to 80 watts. That is less than a light bulb. Europe never stopped using this technology. They call them Canadian wells or Provençal wells, and they are integrated into modern construction today as standard practice. The Passive House Institute in Darmstadt, Germany, has monitored 847 residential earth tube installations since 2005. These systems deliver an average cooling capacity of 3.2 kilowatts, while reducing mechanical cooling demand by 89%. Homes maintain interior temperatures between 72 and 75 degrees without air conditioning, even when outside temperatures reach 95. German building code provides efficiency credits for earth tube integration. In Austria, the national building standard requires thermal labyrinth analysis for any structure exceeding 1,000 square meters. At a hospital in Vienna, an earth tube system has provided 450 kilowatts of cooling to critical care units since 1994. That is 30 years of continuous operation cooling a hospital. Maintenance records show cleaning is required only every 5 to 7 years. In Switzerland, the Minergie certification program has documented performance data from over 200 monitored installations, and a 15-year longitudinal study from ETH Zurich found zero degradation in system performance over the entire monitoring period. Zero. The system works exactly as well on year 15 as it did on day 1. So why can you not build one in the United States? The International Residential Code, Section M1601, requires all ductwork to be constructed of materials having a maximum flame spread index of 200, with no provision whatsoever for earth contact air handling. The code assumes ductwork exists inside buildings and nowhere else. The Environmental Protection Agency classifies 21 states as Radon Zone 1, meaning any earth contact air pathway triggers mandatory mitigation, adding $2,000 to $5,000 in costs, even though European systems manage radon with activated charcoal filtration and ultraviolet treatment for under $100. The International Energy Conservation Code provides zero compliance credit for passive earth cooling. You get nothing for installing a system that cuts your energy use by 90%. The Air Conditioning, Heating, and Refrigeration Institute spent $47.3 million on political activities in 2022 alone. In 2019, ASHRAE Technical Committee 6.8 rejected a proposal to create a performance pathway for earth tube systems, citing insufficient domestic data while ignoring 3 decades of European documentation. Analysis of committee membership revealed 67% representation from HVAC manufacturers. Building codes in most U.S. jurisdictions do not recognize earth tubes as a primary cooling system. You still need to install conventional HVAC to pass inspection, even if you never turn it on. But you can still build one. Here is how. Bury smooth wall HDPE or PVC pipe, 200 to 300 millimeters in diameter, at least 6 feet deep. Run the pipe 30 to 60 meters through the earth. Slope it at a 2% grade, so condensation drains naturally rather than pooling, because stagnant water breeds mold. Place the intake 15 meters minimum from the house, elevated above grade to keep out lawn debris and insects. Install MERV 13 filtration and UVC treatment at the house end to handle mold spores. A small inline fan of 50 to 80 watts keeps air moving when natural convection is not enough. For radon, use an activated charcoal canister at $40 to $60 replacement annually, achieving over 95% reduction. Use sand bedding for stability and careful backfill to prevent settling and air pockets. Gentle curves, never sharp bends. Mark the locations so nobody digs through your system years later. New construction is the easiest time to install. Just trench before the foundation is poured. Existing homes can retrofit by trenching alongside the house and connecting to cold air return ducts or running the output directly into a basement. A DIY earth tube system can cost as little as a few $100s in materials. Professional installations run $2,000 to $5,000. Compare that to a central air conditioning system at $5,000 to $15,000, plus $700 or more per year in electricity to run it. European residential installations cost 3,500 to 6,000 Swiss francs total, with pipe materials alone running just $300 to $400. The average payback period is 12 years. After that, your cooling is essentially free, not reduced. Free. There are 3.6 billion cooling appliances operating on this planet today. That number is projected to hit 9.5 billion by 2050. The electrical grid cannot sustain that trajectory. We know this. Everyone in the energy sector knows this. The ancient Persians engineered a solution that runs on physics alone, using thermal mass, convection, and evaporative cooling. It worked for millennia. It works right now in thousands of European installations. It works in hospitals, in homes, in schools. The technology is not hidden because it is complicated. A teenager with a shovel and some pipe can build a functioning system in a weekend. It is hidden because it does not generate recurring revenue. Every thermal labyrinth installed is an air conditioning unit that never gets sold, a compressor that never gets replaced, a refrigerant charge that never gets topped off, a service contract that never gets signed. The earth beneath your feet has been cooling itself for 4.5 billion years. It has always been waiting. The only question is how much longer you are willing to pay someone to ignore it.